How excess carriers are generated in semiconductors. In semiconductors, excess carriers refer to additional charge carriers, electrons or holes, beyond what exists in thermal equilibrium. These carriers can be generated through various mechanisms. Photon absorption, when photons with sufficient energy, equal to or greater than the bandgap energy of the semiconductor, are absorbed by the semiconductor material, electron-hole pairs can be generated through the photoelectric effect. This creates excess carriers, leading to the formation of electron-hole pairs in the semiconductor. Thermal excitation, elevated temperatures can also generate excess carriers. At higher temperatures, some electrons gain enough thermal energy to break free from their bound state within the crystal lattice, becoming free carriers. Similarly, holes can be generated when electrons in the valence band gain sufficient thermal energy to jump to the conduction band, leaving behind holes in the valence band. Carrier injection. This occurs when external sources introduce carriers into the semiconductor. For instance, in a p-n junction diode under forward bias, electrons from the n region and holes from the p region are injected across the junction, creating excess carriers in both regions. Impact ionization. High-energy carriers can collide with the atoms in the semiconductor lattice, causing the release of additional charge carriers. For instance, when an energetic electron collides with an atom in the crystal lattice, it can transfer enough energy to create an electron-hole pair, generating excess carriers. Avalanche breakdown. In regions of a semiconductor subjected to a high electric field, as in the case of a reverse-biased p-n junction, carriers can gain energy from the field and collide with other atoms, creating additional carriers through impact ionization. This process can lead to an avalanche effect, generating a large number of excess carriers rapidly. These mechanisms can collectively contribute to the generation of excess carriers in semiconductors, impacting the conductivity and behavior of the semiconductor device.